Hello students, let us solve the fifth question in this paper. The table below shows values of x and y for the curve C with equation y is equal to f of x. And using the trapezium rule, with all the y values in the table, find the estimate for the area of the region bounded by the curve and the x-axis between the lines with equation x equal to 0.9 and x equal to 5.1. That is between these two coordinates. Okay. So we can use the trapezium rule formula here, which is given in your formula booklet. So we can use that, and this is the formula. Okay. So this y0 and yn are the first and the last coordinate. So here of y. So here this is your y0 and this is your yn. So these two terms you just need to add them, and other terms you add them completely and multiply it by 2. So I'll just rewrite that portion, and h is the interval. Okay. So here the interval, for each interval it is point of 0.6 duration, so h is equal to 0.6. So all you need to do is just plug in the values over there. Y0 and yn are equal to, both are equal to 1.5 each, so it is 1.5 plus 1.5, and the other terms are 0.48, 0.3, 0.26, 0.48, 0.3, 0.26, then one more 0.26 and one more 0.3, I think, and 0.48 also. Okay. Okay, so this is what we need to do. Now you can use your calculator over here. If you do the calculation, you will be getting the final answer as 2.148. You can round. Have they mentioned any significant figures? No. So if they have not mentioned any significant figures, you can round it to three significant figures. So that is equal to 2.15, which is the correct answer. Okay. So the mark division for this is, for specifying or using the h value as 0.6, you get one independent mark for this particular value, and this whole step you will get one method mark, and the correct answer carries the accuracy mark. Okay. Okay, now coming on to part B, if you look at the question, it looks like a very whole lengthy question, but it's a very easy one. It's not even worth 3 marks, I would say. It's a very easy one. Okay, so this whole thing is just explaining what the figure is, what the dimensions are. Everything is given in the figure, but they're just explaining it once more. Okay, so figure 1 shows a sketch of the solid concrete skateboard ramp, and figure 2, this is the cross section of it. That means if you cut this maybe somewhere in the middle or anywhere on top, you will get a layer of cross section like this. Okay, that's what figure 2 is all about, and all the dimensions are given here. I'm not reading the dimensions. So use the answer to part A, find an estimate for the volume of concrete in the ramp. Okay, so in part A, what we had is, we had this curve only. This is the curve which is given in part A, and what we found was the area under the curve and the x-axis. This is the area that we found in part A. Okay, and this was equal to how much? It was 2 point. Okay, I'm not using the rounded up value. I'll use the exact value over here, which was 2.148. Okay. Now we know that volume is nothing but equal to area multiplied by height. Okay. So we find the whole cross section area, and then if you multiply by the height or the width. So here this is the width. Okay. Then we'll be getting the volume. Okay, so the area of only the red portion was calculated in part A. So this is the only thing that we calculated in part A. Now we need to calculate the area of the blue portion. So this is one portion, and this is also another portion, but this is the same. Okay, as you can see that the first rectangle is having a width of 0.1 or 0.9 and the length is 1.5. The same happens for the other one also. Okay, so the area of rectangle 1 and rectangle 2 both are equal to this. Okay. Okay, now the total area we can calculate. So total area is equal to, okay, I'll write it separately because the figure was there. it is better to write it over here because it would be helpful. When you're writing the exam, just do it on the paper, the main paper itself, because you can turn around the pages. But here, to explain with the figure, this is more easier. Okay. So total area is the area. Okay, I'll write this separately. The area of the curve plus the area of the rectangle 1 plus the area of the rectangle 2. Area of the curve was 2.148. The area of both the rectangles are zero point 0.9 times 1.5, which is equal to 1.35. So this is 1.35. I mean this value, okay, is 1.35. So the total is now going to be 4.48. Okay, sorry, 4.848. 4.848. This is the area. Now if you multiply the area by the height, that is 4.848 times 2.5, which is the width, this is going to give 12.12 meter cube. This is the volume. If you round it to three significant figures, it is going to be 12.1 meter cube. So this is the answer for the second part. Okay, now in the last part, we are told that giving a reason, we need to state whether the answer we got just now in part B, that is this answer. Okay, the mark division also we didn't discuss. The mark division for this one is if you find the area of the total side, that is this one, that carries the first method mark. And for using this formula or that method, you get a dependent method mark, and this is the final mark for the correct answer. Okay, now we need to find with reason, we need to state whether this is an overestimate or an underestimate of the true volume of the concrete in the ramp. Okay, so the only estimate that we took was over here in part A, where we calculated or estimated the area under the curve. So for estimating the area under the curve, I'll use a figure over here, similar figure over here. So this was the curve, and we took the area under that particular curve, right? So to estimate the area under the curve, what we did was we were using trapeziums of 0.6 width. So this was the trapezium that we were using. So you can see that the actual area is only the red shaded part, but we were also finding this orange shaded part area in when we calculated the trapezium, because using the trapezium rule, we are dividing the whole area into different trapeziums, right? So when we calculate the area of the trapezium, we are including this portion also. This is also included. Okay, so that means the area is actually a overestimate. So what area we calculate using trapezium rule is actually more than the actual area, which is this shaded portion. This is the actual area. So this portion is also included. So the last one is actually a overestimated area. Okay. So the reason is like the trapezium which we consider over here have a bigger cross-section area, and that is the reason for the overestimation. Okay. So I hope you understood it. Thank you so much.